Hello everybody. Now we are going to implement the simplified Boolean function with the two-level NOR gates, and the question is 3.19 from Digital Design by Moris Mano's 5th edition. Let's start with the first problem, that is the A problem, that is the function of w comma x comma y comma z, that is equal to w x dash plus y dash z dash plus w dash y z dash. So this is the problem, and we are asked to implement the function using two-level NOR gates, but this is available in SOP form, and this SOP form must be converted into POS. Then only it is easier for us to implement it using two-level NOR gates. Okay, so first let's mark the midterms into this K map. So here we have wx dash, isn't it? So that can be marked here as wx dash. So it is related to all these, this row, and all these midterms are covered 8, 9, 10 and 11. Then we go for this y dash is a dash. So where is it? It is y dash is a dash is here. Okay. So it occupies this column. So it is 0, 4, 12 and 8. Then next one is w dash. So we look at here, and also this y is z bar. So y is z bar is this one. So corresponding to this we have this 2 and 6. So the next step is we have to mark the zeros here corresponding to the rest of the midterm cells. Now we can mark the groups here. So it can be marked like this. These four zeros can be combined and it can be marked as loop 1. And for this the corresponding expression is these two rows and these two columns. So w bar x and w bar x dash. So that means w bar becomes w, and here this x dash x get cancelled. Here y dash y is cancelled and z is available, so we must write it as z bar. This is for loop 1. Then we go for this loop 2. So loop 2 is occupied, loop 2 covers this 5, 7, 13, 15. So this is our loop 2. So for this we have these two as well as these two, isn't it? So okay, w dash w get cancelled and x is available, that should be written as x dash, and here this y dash y is cancelled, so we get this as z dash. Then the last loop 14th and 15th cell can be combined, and this can be marked as loop 3. So corresponding to that we have this wx here, and here we have this yz and yz bar. So wx can be written as w dash plus is x dash plus here this y dash. So this is the simplified expression. Okay, so now we can form this f by combining them. So f simplified is equal to w plus z dash, then x dash plus z dash, then we have this w dash plus x dash plus y dash. So now we can implement this using two-level NOR gates. As we have four variables w, x, y, z, we draw four lines, and these are the input lines from which we have to take the connection for the implementation of this logic diagram using NOR gate. Okay, so the first term is here, it is w plus z dash, isn't it? So we have to take the connection from here w, then we take the connection from this z. So this must be inverted, so we get this z dash, and these two must be given to NOR gate. X must be inverted to get x dash, and similarly z must be inverted to get z dash. So here we get x dash, here we get z dash, then they are given to NOR gate. Similarly we go for the third one. So for the third one, w dash, x dash and y dash, they must be r. So we take the connection from this w, it must be inverted, then x, it must be inverted, then y, isn't it? It must be inverted. Then we take the connection out of this inverted. inverter, which is given to NOR gate. Then these three must be connected to another NOR gate. So this gives the required output for us. So we take the connection out of this another NOR gate so that we'll get this F simplified. So to get the implementation using NOR gate, you can have this POS form. Okay. So if you have the POS form, directly you can play each and every term as such and given to the NOR gates. Then you will get the proper function. Okay. So the first problem is over. We move on to the second problem. The second problem is f of w x y z is equal to sigma 0, 3, 12, 15. So we can mark ones into this 0, 3, then 12 and then 15. So in order to convert it into POS form, we can mark with the zeros to the rest of the cells. So here on 0, 0, 0, 0, 0, 0, we have 0, 0, then we have the 0, 0. So we can now form the loops. So this can be formed as a loop. It consists of the cells 4, 5, 6, 7. So this can be named as loop 1 and its corresponding expression is w dash x allowed. Here it becomes 1, isn't it? Column wise. So it can be written as w plus x dash. Then we go for the second. This one we can make the second loop 8, 9, 10, 11. This is loop 2. For this the corresponding row wise it is wx dash. That should be written as w dash plus x. We go for third group. So it is by combining these four zeros together. 1, 5, 9, 13. So this is loop 3. So here column wise we have this. Row wise it becomes 1. So it is y dash z, isn't it? That should be written as y plus z dash because it is in POS format. Okay. Then we go for the fourth group formation by combining the zeros at 2, 6, 10, 14. This is loop 4. Its expression is y dash plus z. So now the simplified expression is, if simplified is w plus x dash, then w dash plus x from loop 2. From loop 3 it is y plus z dash and y dash plus z from loop 4. Now we can implement this using NOR gates only. So that means the logic diagram, isn't it? So we are going to draw the logic diagram for this. So we start with the input lines. We are going to draw 4 input lines W, X, Y, Z, and we name them W, X, Y, Z. So we go with this first term line from this W, then from X, but this should be inverted using NOR gate. Then you draw the line. They must be applied to NOR gate, isn't it? Okay. Then we go for this W dash plus X. So take the connection out of this given to one inverter, and for this X take it from here and give it to one NOR gate again. Then we go for this third term. This is Y. So Y must be directly taken, Z must be given to an inverter, then Y dash plus Z given to an inverter, Z is taken out of here, given to another NOR gate. Then these must be connected to, they must be given to another NOR gate. Then we'll get this F simplified. This is the answer. Okay. Now we move on to the third problem. So this is the third problem, C problem, right? So we can write it. C problem is f of x comma y comma z, that is equal to x plus while then multiplied by, it is given as x equal to, maybe it is typo, so we write this as x plus z the whole dash. So it is in the form of product of sum, but again it is inverted. That's the difference. Okay, we want to simplify it. Okay, so I'm going to expand this as, so we are going to apply distributive law between these two. Okay, so that we'll get this as x plus x z plus yx plus yz the whole dash. We know that this xx becomes x plus xz plus, this can be written as xy plus yz the whole dash. So if you take x outside, it is 1 plus z plus y plus yz the whole dash. So this is equal to x into 1 plus anything is 1 plus yz the whole dash. X dot 1 is x, so we get this as x plus yz the whole dash. Then if we apply dash to it, it becomes x dash dot yz the whole dash. So that is x dash dot yz the whole dash can be written as y dash plus z dash. So this is not in proper POS format. To convert this into proper POS format, x dash can be written as x dash plus x dash dot this y dash plus z dash. So now we get this in POS format. For this we can draw the circuit diagram very easily. That means we can draw 3 lines which are the input lines. So that corresponds to x, y, z. Now we take the connection from this x and given to an inverter which is a NOR gate. Similarly again, you take the connection out of here, you can give it to another NOR gate. So this is x dash plus x dash. Then we go for the second term. Already this is over, right? Y dash plus z dash. So we take the connection out of here, y, giving to NOR gate z, then give to inverter which is a NOR gate, then they are combined or they are being given as input to another NOR gate. These two NOR gates are now giving inputs to the next stage of NOR gate. There you get the F simplified. Okay, so this is the answer. Instead of using these number of gates, if we want to get the simplified one, this can be actually terminated and we can directly connect it because only we need x. Okay, because we want to reduce the number of gates being used. Okay, thank you.